Hi, we're going to talk today about information, and this is really a incredibly fundamental observation that Ron Cowen made, and we just want to point out how important it was. Um, the thing that drives this is a classic experiment that was carried out in the 1920s, and it's been repeated many times since then. The experiment is called the double slit experiment, where people would take electrons, for example, and shoot them at a screen, and the screen would have a slit in it, which was wide enough for a single electron to get through. So if you shot a bunch of electrons at the slit and you had a screen behind the screen that you cut the slit in, then you'd see a line of electrons hitting there. That's great. Now, the thing that's confusing is if you put in two slits, then the electrons ought to go through either one slit or the other slit. And when you look at the screen behind it, you should see two lines of electrons hitting. But in fact, what was observed was you had not simply that, you had a wave pattern of interference between, again, the electrons apparently turned into waves when they got to the slits, and they then scattered out from there and created positive and negative interference of the wave fronts to create a interference pattern. It was centered around the two slits. The greatest strength was around the two slits, but there were peaks and valleys going away from that. And this is like impossible to figure out because the electron is viewed as a particle. And if it's a particle, then it's a particle. But if all of a sudden there's two slits, then it turns into a wave. How could this possibly be? So this is what Ron Cowen observed. And let's go back to his fundamental observation here on the electron. The electron itself, here's a picture of what he observed. The electron has these 10 closed strings here, and they wrap around the electron. Here's the electron here. The electron happens to be a torus with a hole through it, but it's covered with these information blocks. And this is the novel side of things. So the information blocks that are there, they're actually stacked up like this. Here's examples of waves that Ron observed on the surface of these blocks of information. What he observed was that the electron information blocks were always scanning in all directions. So when they detected a change, they would react differently. And the reaction was based on the algorithms that were contained in these information blocks. Now, the information blocks algorithms are in fact the laws of physics. So what happens here is the electron, when it senses there's only one slit, it behaves just like a particle would behave. But as soon as it saw that there were two slits there, which it's constantly scanning, and apparently these scans are taking place at faster than the speed of light. They're literally instantaneous. As soon as the scans detect that what's out there has two slits in it, the electron that Ron observed turned into a wave, and it just went for it instantaneously and created the interference pattern that was seen in this experiment. Now, in the 1920s, this was, again, when the experiment was first done. Louis de Broglie, who received the Nobel Prize in Physics for looking at the duality of waves and particles, matter, Louis de Broglie said maybe there's some sort of pilot wave there that's causing this to happen. He's looking for an explanation of this. And in fact, he was onto what was going on. Another individual, David Bohm, in the 1960s, 1970s, et cetera, David Bohm felt that there was also a pilot wave here, and he constructed a theory of quantum mechanics that was self-consistent with all the existing quantum mechanics, but involved a pilot wave, is what he called it. So something that was scanning all the time to make sure that everything was synchronized throughout all of space and time. And so David Bohm was onto the right thing as well. What Ron Cowen did was he actually showed the mechanism by looking at the blocks of information and the scans that took place from them. And these cover, remember, not simply the electron, but they cover the compartments of space, the quantized foam that makes up space all around us. And so everything everywhere is continually scanned, and then synced. And this is an incredible accomplishment to observe this. And it shows the hand of a master at work, that the synchronization that takes place, again, occurs everywhere. Everything gets synchronized, but it's simple enough that it can work. It's a very elementary, very skillful approach to doing this. So with that, let's call it a day.